ठीक है, you can start.
Bismillahirrahmanirrahim. Today we are going to talk about renewable energy resources, technology development endeavor. This basically is an endeavor. I'll start off with solar radiations. Till 1986, there was no solar radiation data published in Pakistan. So a book was published in 1986 which had the essential data for solar radiations. It was named as Solar Energy Guide and Data Book for Pakistan. It was designed for those users who use solar energy either for designing or for personal consumption. This gave data for each month for radiations which falling on a horizontal surface like tabletop or rooftop in megajoules per meter square. In January, February, March, April, May. Today is May, and today in Karachi the flat surface is receiving around 23 megajoule per meter square, and if there's a house 10 meters by 20 meters, 200 square meters, that means that should be receiving about 4,600 gigawatt hours, gigajoules, which is extremely high. It's very, very high. And this kind of thing has been calculated for each and every month of Pakistan and 20 different cities in the country with contour maps for each and every area. From this we actually find out what is the maximum slope on which the radiation falls, which peak. For example, in the month of different months, in summer months, flat surface in Pakistan receives the maximum energy from April to September. That means our roofs, if they're tilted, then we can reduce the heat gain in summers in those areas. Then this each and every month for 20 major cities has been evaluated for at what angle would you like to have the solar energy, solar cells placed or solar geysers placed to get the maximum energy. So for January, February, March, April, May, June, each and every month, the information is available that helps you or designers or users to either change their slopes of the photovoltaic cells or the geysers every month, or they can decide to change it after every quarter or twice in a year. Now this data is very essential because you can get maximum output in winters and summers separate. After having done this radiation information, then we started developing certain products because everybody wanted to have some products, not data only. Then we designed things, for example, first was solar thermal power, where we produced steam from solar energy, and we had parabolic troughs which was designed on similar lines as were being used in Lewis power plant in America, and we designed and developed the complete parabolic mirrors, its support structure, its absorbers, and the evacuated tube. And for every portion we had a master's or undergraduate project which completed. And you could actually see from two mirrors focusing onto a line, focusing somewhere around 2 kilowatts of energy in an evacuated tube, and that tube converted water into steam, and steam at high pressure and then fire. So we named it as steam gun. This project was subsequently funded by the Ministry of Science and Technology and Pakistan chapter of UNESCO of Ministry of Education. And in the same thing, we actually developed the complete solar system lab at College of EME, NUST. And subsequently 5.8 meter aperture area parabolic trough mirror system was developed. Thereafter this research has changed, and no further work has been done on this. And if we have the complete component of this system, we have the complete solar field developed in Pakistan with Pakistani laborers, Pakistani industrialists coming into play, thereby saving around 30%, addressing the 30% of the power plant, whether it's 1 megawatt or 50 megawatt, by indigenous components. Then we developed a Stirling engine, a small Stirling engine, 60 watts or so, and it was operating on one parabolic dish mirrors, again locally developed. So designing of the dish mirror was done and fan was operated on that. Subsequently, a new Stirling engine was developed during a master's thesis, which was designed for 200 watts. It operated for some time and then the student left. And we also developed a slightly larger model of Stirling engine, which was designed in collaboration with a designer in Lahore. And again, thereafter, further work was not continued in this area. We've also developed solar concentrating cookers and solar box cookers of different types. The concentrating cookers are very unique because they use same dish mirrors which we are using for parabolic Stirling engine concentrators, and this focuses around 1 kilowatt on the base of a cooker, and this was demonstrated in Islamabad, in Lucky Bear, Punjab, and it produced very good results in cooked food in the same time as gas. We also developed solar box cookers, a technology which is there for decades, and it was indigenized, locally developed, demonstrated, and it was designed for large-scale manufacturing. However, it did not pick up in Pakistan despite of the fact that it's low-level technology. And during the same time, on the PC1, which was approved through the Ministry of Water and Power and Cabinet Division, we developed a complete solar solution, a composite solar solution for a village in Sindh and Balochistan. In Sindh, we installed a solar lighting system with 4 lights and parabolic cookers and solar desalination system, because the people over there would drink brackish water, almost brackish water, which one can't think of drinking. And the composite solar solution provided them with energy, and it changed their lifestyle drastically. And lighting systems in Bharmal Sindh can be seen here. We also developed a solar water pumping system to pump the water for subsequent desalination from solar thermal desalination. Now this system is there, being installed, it's operational. A few sketches are here where we train the local people there, living there, and there was a lot of people interest in this. And systems are doable, they need to be replicated, and we had trained local people to actually replicate the same, and I hope it is still being used. We also developed a very unique system for Pakistan. In fact, whenever we talk of energy, we talk of electricity, and whenever we talk of heat, we talk of air conditioning, but we forget that we can actually reject the heat which is causing the cooling load or overheating the houses. So we developed a solar heat resisting roof tile, a special roof treatment sort of thing. What we found out was that an average house in the southern part of Pakistan, roof which is red to grey cemented, achieves 60 to 65 degrees centigrade roof temperature in peak summers, and it continues to heat at that temperature for 8 hours or so. Thereby heat is conducted downwards, and the roof on the lower side gets heated to 40 to 45 degrees centigrade, which is not comfortable for a human being. That's why we continue to get hot air blowing from the roof till 10 p.m., 11 p.m.